Hi everyone, I want to record this short video on a 4-point butterfly, and let's just go to it. This is actually from the classwork, and I'll probably do more examples on different types of maybe exams or past exams, quizzes if there are about this. So let's just get to it. So what you want to do is I want to take the 4-point butterfly of this x of n. So I'm going to interpret this as in the form 0, 1, 0, -1. Because this is delta of n minus 1 shift and delta of n minus 3 shift. So this is starting at n equals 0, n equals 1, n equals 2, and n equals 3. And what we do is we group these by even and odd terms. So these two are my even terms and these two are my odd terms. So what I'm going to say is a1 is equal to the even term, the first even term, which is just 0. Next, the next term, the second even term is x of 2, which is also equal to 0 in this case. And next, the odd terms are x of 1, a3 equals 1, and x of 3 equals -1. Now, what I'm going to do is to get these intermediate b1, b2, b3, b4, first of all, I say that b1 is equal to what I would call xe of 0 by the convention in the class. And what is this going to be? I'm going to follow this diagram. It's going to be a combination of A1 and A2 just added together. So that's going to be A1 plus A2, and that's just 0 plus 0 equals 0. Next, I'm going to solve for B2, which I call the second even term, or 1. And it's going to be the difference. A1 minus A2, because of this here, this -1 here, A2, but it's just also 0 minus 0 equals 0. Next, B3 is equal to the sum of A3 and A4 by following the trail. And this is actually the odd term, x, capital X odd of 0. And we say that's okay, that's A3 plus A4. And in this case, that would be equal to 1 plus -1 is -1 equals 0. And by B4, this is what I call the x odd of 1, and that's going to be the A3 minus A4. And that's going to be 1 minus -1 equals 2. So you're starting filling out this diagram. This is 0, this is 0, this is 0, this one is 2. So let's say I want to calculate C1 from here. I'm just going to keep on following the trail of this diagram. So this C1 is telling me it gets contributions from B1. This could be B1 plus this diagonal term. And that would be, you got B1 plus B3. So B1 you got earlier was 0. B3 is equal to 0. So you got 0. Next, you get C2 is equal to, okay, I'm going to follow this trail on the middle. It gets B2. It's going to get this diagonal term minus J times B4. And that's going to be equal to, okay, B2 was 0 minus J times 2 equals -2J. Okay, C3 is going to be equal to, let's see. So C3 gets contributions from B1 along this diagonal. So I get B1 minus, it's a little bit hard to read, I guess. B1 minus, let's see, B1 minus this term. That's that minus 1 times B3. That is an incredibly hard diagram to see. So this would be 0 minus 0 equals 0. And now C4 is just going to be equal to, okay, C4 gets a contribution along from B2 plus J times the contribution from B4. So in this case, that would be 0 plus 2J. And that's equal to 2J. So my diagram is complete. This is going to be, this first one here is 0, -2J, 0, and 2j, and this would solve your problem. So I believe that's correct. And what I'm going to do is, okay, let's say I want to now do the same thing, but I want to do it for h of n. So I'm going to just sort of take the time to just erase everything. One moment. It's probably a faster way to erase somehow, but that's okay. Repeat the same thing. Okay. So I'm going to h of n. I'm going to interpret that as a 4-lane signal. So it's going to be 3, 2, -3, -2. This n equals 0, n equals 1, n equals 2, n equals 3. You group the even terms. So this is going to be, let's see, x of, well, we're in h now. H of 0 equals 3. H of 2 equals -3. H of 1 equals 2. H of 3 equals -2. Okay. And I forgot to erase these. Now, I want to solve for B1, B2, B3, B4 now. So I'm going to say B1 equals the sum from A1 and A2, or in this case, that'd be 3 A1 plus A2. That'd be 3 plus -3 equals, well, that's not right. Yeah, that's right, 0. Next, B2 equals the diagonal term from this way, A1 minus A2. And that would be equal to, let's see, 3 minus -3 minus -3, and that'd be equal to 6. Next, B3 equals, let's see, it gets contributions from A3 and A4. So it'd be A3 plus A4 is equal to, let's see, so 2 plus -2 equals 0. And you get that B4 equals the A3 minus A4. This would be 2 minus -2 equals 4. So currently this equals to 0, 6, 0, and 4. Now to calculate C1, C2, C3, C4, we have C1 equals, let's see, the contributions from B1 and B3. So B1 plus B3 is equal to, let's see, 0 plus B3 equals 0. C2 is equal to this term going across. So B2 minus the J diagonal minus J B4 equals 6 minus 4J. C3 equals, this is my hardest one to read. It would be B1. I think when you see this -1, it's actually up on this line. So minus B3. And that would be equal to 0 minus 0 equals 0. And you get C4 equals, let's see, C4 equals the contribution from B2 minus this part is J. So plus J plus J plus J B4. And that's equal to, let's see, this is 6 plus 4J. So to fill in the answer, this would be 0, 6 minus 4J, 0, 6 plus 4J. And I think that completes the problem.